In this video, we're going to talk about how to find the inverse of a function. And specifically, we're asked to find the inverse of g of x is equal to negative x plus 3 all over 5. Now you can see on the right-hand side of the screen, I have written in green the 4 steps to finding the inverse of any function. Anytime you want to find the inverse, you just go through these steps. The first one being replace the f of x, the g of x, the h of x, whatever function notation you have, you want to replace it with y. So let's go ahead and do that for this problem. So in the place of g of x, we're going to write y instead. And so we're going to say y equals negative x plus 3 all over 5. So it's not a very hard first step. You just switch your f of x, your g of x out for y. Now the next step shows you why we do that, because you want to switch all of your x's to y's and all of your y's to x's. So it's a little bit cleaner to do this if you have a y than if you have, in this case, a g of x, because then you'd have g of x's all over the place, and it would just be a little bit more complicated. So what we're going to do is we're going to, instead of having y equals negative x plus 3 over 5, we're going to rewrite this using step 2 as x equals negative y plus 3 over 5. So if you had multiple x's, you would now have multiple y's. If you had multiple y's for some kind of crazy reason, you would now have just one x. But of course, that's not going to happen because we're always going to be given a function to start out with. So you'll always just have one x after this step. Then the next thing to do is to resolve for y. Not really resolve, but to resolve. So what we want to do is get y by itself. So the first thing I'm going to do is I'm going to multiply both sides of what we have after step 2 by 5. And what that's going to allow us to do is it's going to get rid of the fraction on the right-hand side. It's going to leave us with 5 times x is equal to negative y plus 3. Now we need to get the 3 across. We need to move it by subtracting 3 from both sides. So I'm going to subtract 3 there, and that'll cancel our 3 out, leaving us with 5x minus 3 on the left-hand side is equal to negative y. Now we want to get y completely by itself, and currently we have negative y, so we need to multiply both sides of this equation by negative 1. So multiplying negative y by negative 1 is going to result in positive y, which is what we're looking for. And multiplying the left-hand side by negative 1, I'm going to go ahead and distribute this negative to both of those terms. So that's going to give us negative 5x plus 3, because the two negatives are going to cancel, is equal to y. Now we've resolved for y, so we go on to step 4, and that is to replace y with the inverse notation. So instead of having y here, we want to rewrite it, indicating that it is the inverse, in this case, of g. So what we're going to say is we're going to say g negative 1 of x. That negative 1 indicates the inverse of g is going to be equal to negative 5x plus 3. And that's it. That would be our answer. Now, if you wanted to check, go back and double check and make sure, let's say you're on a test and you have some extra time, that this is in fact the inverse, you can always determine if two functions are inverse of each other by plugging one into the other. If it simplifies to x, then that's good. Then plug the other into the one and simplify it. In other words, find the f of g or the g of f. And if it simplifies to x in both cases, then they are inverse functions. So you can always check yourself if you want to, but if you follow these steps, you should be good to go.